Hey Jaden, how you doing?
Hey Nick, I'm doing pretty good.
I was beginning to think somehow I was in the wrong place for the wrong time because officially class just started and you're the only one here.
Yeah, this usually isn't the case.
Well, we'll assume other people are coming. So, do you know if have you talked to Ben? Is Ben going to be able to come so that you guys can do your thing?
I mean, I haven't heard anything otherwise.
Then let's hope that he shows up. Um, and I had a conversation with Utkarsh just a little while ago, so I presume he's around. And there's Joe. Hello, Joe.
Um,
A question for Joe. Were you and Utkarsh done on Thursday, or do you still have more stuff to cover? I don't honestly remember. I mean, on Wednesday.
oh, we were done.
Okay, so you're finished. So we just have Jaden and Ben to do today. Okay, that is good to know. And there's Ben. Awesome. Oh, I should allow screen sharing. So, Jaden and Ben, if you two want to go ahead and get started or get your stuff up, we'll wait a second more before you actually start, but you should have permission to share. So feel free to do whatever setup you need to do.
It should be showing the right
Yep.
thing.
Well, we're looking at Machine Shop Simulator Refactoring Round 2, Jaden and Ben.
All right.
It's like Google Slides to me. Well, let's go ahead and start because we know that some of these have taken a while. So go ahead and roll out, and we'll assume some other people will show up as time progresses. So go for it.
Okay. Okay. Um. So round two. Yep. So what I ended up focusing on personally for this one is looking at Machine Shop Simulator as a large class and trying to shrink it down by moving methods out of it into other classes that they should potentially be in. So I looked at the change state method, move to next machine method, and set up jobs method. Um, for change state, I basically just pulled the bulk of it out and put it into machine.java as process work. Um, yeah, it's pretty self-explanatory. For most of these, if not all of these, I used IntelliJ to refactoring tools to extract and move.
So why
Um,
did you decide to move it to machine?
because I guess to me, it felt like it would work better in machine. Um, and maybe that might not be the case, but I do remember us talking in the last round about moving the most of it to machine and trying to do whatever with elists so it works properly.
No, I think there's a good argument for moving into machine, and that is it refers to machine all the time,
Yeah.
right? There's like a lot of machine dot this, machine dot that. So I think you can make a good case to answer that question, which is that most of what's happening seems to be asking machines for things. So let's just move this into machines so we don't have all these machine dots everywhere. I
Mm-hmm.
think that's a perfectly reasonable case. So cool.
And then let's see, this is the rate function, right? Yeah. I had it brought up to me that I probably shouldn't be using the whole machine shop simulator object as a parameter.
Yep.
And yeah, we talked about that with Jacob's group, I believe. So I went through and was more specific with which parameters to put in.
Mm.
And then looking at setup jobs here, basically the same thing. Though this one, I just moved the whole method. I didn't do any sort of extraction.
Well, oh, so you just did it by hand as opposed to using like IntelliJ or something to do it for you?
No, I didn't do it by hand. There was a thing called move instance method, and I
Right.
used that.
Gotcha. And this is actually a really interesting example because notice that the argument went from being a simulation specification to being a machine shop simulator. So it used to be in the simulator, so it had access to all of that stuff, but it needed to access the specification stuff. And then when you move it, it magically has access to all the specification stuff, but now it needs machine shop simulator as an argument so it can reach back and get to the things that it used to be able to get to from machine shop simulator. So that's actually sort of a really interesting example. And then presumably any place where it used to have to ask for things for the specification got simpler, and then things that it had access to now became more complicated, like what you're pointing at with the machine shop simulator.get machine. That's very cool. Cool.
Yeah, that's like the only trade-off I found is it uses specification twice in here, and then it only uses machine shop simulator dot once in here.
Gotcha.
Which I might be able to specify it further down potentially instead of just the whole thing of machine shop simulator.
Yeah, right. That would be an interesting question is could you somehow pass a little less to the new setup jobs? And I'd have to think about that more than I probably have brain power for right now, but yeah, great question.
And I did do a little playing around with it with where it says get machine here. I tried to pass. I think I tried to pass the right thing, but it was not being nice at all about it.
Gotcha.
And then the last one I did was move to next machine. This is a case where I re-looked at it again not too long after creating the pull request and saw that MSS is being called all over the place. So I actually moved this back into Machine Shop Simulator.
Gotcha.
Yeah, and that's the most I have there. And then moving forward, it would be like Utkarsh brought up the point that the next step would probably be to remove the parameter of Machine Shop Simulator. And I did do some of that in IntelliJ after it was brought up to me. It's not exactly reflected in the slides, but I think I can, I do have Git pulled up so I could show a little bit of that. Otherwise, my next idea was trying to attack some of the middleman stuff and then reducing machine shop further if I can.
Although, how big is Machine Shop now?
Now
you said it started out like being 200-ish lines.
Yeah.
Have you? I assume it's non-trivially shorter these days.
Let's see. Machine. Looks like it's 183 now.
Oh, so it's a little shorter.
It's a little.
Yeah. All right.
Also,
Cool.
I don't know why Git decided that I removed the whole thing and re-added the whole class.
That's usually a spacing issue when that happens, but I don't immediately see that here.
The only thing I did was just moving the spec into Machine Shop, but
That's
I don't know why.
That's really strange. I don't know.
And then yeah, just highlighting the changes I did there.
Right. Oh, so this
That's
is where you were trying to make it not be the whole simulator, but instead just pass in certain parts.
yeah.
Yeah. Cool.
Let's see real quick. I did add grabbing the event list like this and putting it into process work. I don't know if this is the best way to do this. I don't know if you had thoughts on that, Nick.
So why wouldn't you have done that? I guess, did it used to just say get E-list in the last job, or I
No,
guess I'm
this
not
didn't
sure.
this didn't exist in this method.
Okay. And you needed it to be able to pass it through to process work.
Yeah, unless I made process work static in some way.
No, that doesn't seem like a good idea.
Yeah.
So no, I think this is entirely reasonable. I don't think there's anything wrong with that. I think that yeah, I think the large time and time now and the E-list are a weird trio of things that tend to often be together, and two of them are ints and one's a queue, and it's a strange piece of data, and I don't know that I have a brilliant solution for what to do about those. But certainly I don't have any problem with what you did on line 56 and then passing it to 58. I think that's better than passing the whole machine shop simulator, certainly.
Yeah.
So no, that looks fine to me. And I think one thing I was going to say, like, you have an advantage here that you don't necessarily have in setup job, because here you're extracting something and moving it. And so you can kind of set things up, get the pieces you need, and then pass them. But by moving all of that other method, you're kind of, you'd have to go find all the places that it's called and see what, if you were going to not pass the whole machine shop, but pass just parts of it, you'd have to look at every call and figure out, well, how do I get the pieces I'm going to need to pass through? And it's easier just to pass the whole machine shop simulator and not have to think. But you'd have to do some thinking to set that up. And maybe an alternative then would be to have tried to extract, instead of moving the whole method, extract a sub method out of it that has the right components pulled out, so you don't need to pass the whole machine shop simulator. But I'd have to, yeah, not entirely sure how that would play out. So, so what were you going to say about this part?
I think that was that was the most of what I had.
Cool. Oh, and I think that thing you were showing us, yeah. So you've got setup jobs this versus setup jobs get machine. Oh no.
Oh yeah. Ben pointed out to me that passing this might potentially also not be the best way to go about things.
Okay.
So I tried to be a little more specific with that as well.
And I agree with that completely. Yeah. Good. Cool.
I have a question.
Yes, go for it.
Just because I haven't seen this before, and me and Joe kind of speculated about this. What is this? Like in this context, the way it's, I've never seen, like, I didn't know that was something you could do. I know you can do this dot like name of a method for a method in that file.
I also had run into that.
So in Java, and there's something similar in most object-oriented languages, you often need to be able to refer to the object, to the yourself, the object that you are, or that you're in, and this does that. This is a so imagine, so in this case, we've got a machine class, okay? There can be many machines, right? There could be dozens, hundreds of machines. And so if you need to refer to a particular machine, and that particular machine is yourself, this will do that. Now, what Jaden's showing on line 19, this is not necessary, where it says this dot active job and this dot job queue. neither of those thises are actually necessary, because if I refer to active job, it's going to look locally in new active job, not find a declaration of a variable active job. So then it's going to go out to the machine class and say, is there a field called active job? And it's going to be like, yes, I found one on line 11. I'll use that. This dot active job just sort of short circuits that search process and says, I'm looking for a field active job in an object. Which object? Me. I'm looking for the active job field in me. And similarly for this dot job queue, that just is a short circuit to line 7 saying, I want the job queue in me. But you could have just said job queue and it would have been like, is this locally scoped in new active job? Nope. Is it available inside the class? Yep, there it is on line 7, and I'll use that one. So those thises are not actually necessary. A more interesting case is line 27 of what Jaden's showing us. Set wait presumably takes a machine and the time now from the simulator. And it sets the wait time probably for that machine. Is set wait visible, the definition of set wait visible easily, or is it going to be like long way away from here?
It's right here.
Oh, it's right there. Duh, I was looking down instead of up. Okay, so thank you. So 27 calls set wait, 22 does the work, and it says machine.total wait is machine.total wait plus time now minus blah, blah, blah. And it needs a machine to act on because it's updating the total wait on a machine, and it's using the active job.getArrivalTime. Now this is actually quite weird. This only needs the definition set wait only needs the machine, and therefore the this on line 27, because it's static. If it was not static, you could, line 27 could become just set wait, machine shop simulator get time now, and then any references to machiney bits on line 22, you could lose the machine dot. You could just say total wait equals total wait plus time now plus active job.getArrivalTime. And then when it's trying to figure out what total wait you mean, it would just be my total wait. But here, for I don't know what reason, I suspect it might be like some refactoring thing. And it could be that like IntelliJ did this because it didn't really understand what was going on. But because it's static, it's not, set wait isn't in an object. It's sort of floating in the class outside of all the instances. And so it won't know which machine you mean. So you have to pass this on line 27 as a way of saying, which machine? Me. And then that causes this machine to get passed as an argument to set wait on line 21. And then line 22 can refer to components of it in, 1, 2, 3 places. So this is just a name for the object that you are. I have no idea. Did that make any sense? I said a lot of words, but I don't know if I helped.
Yeah,
It made sense to me.
I had that happen in the first round of refactoring where I had a method that was passing this, and it was a little confusing. So that helps.
So did what I say make sense?
Yeah,
Okay.
I think so. I think I
It's a-
have it right.
It's a weird thing, and you don't usually need it. The place you're most likely to see it is actually, and this is what you probably are all familiar with, is in constructors. You'll often see like this dot thingamadoogie equals thingamadoogie. And the reason for that is just a naming thing, because let's say I've got a class circle and it has a constructor that takes a radius as an argument. Calling that argument radius seems like a reasonable thing because it's the radius. calling the field radius also seems like a reasonable thing because that describes what it is. Well, I want to assign the value in the argument to the field. If I just refer to radius in the constructor, it will scope to the parameter because it'll look locally first and say, is there a thing called radius? You can, and it says, oh yes, there is a thing locally called radius. It's the argument. And so it would refer to that. But we also need to be able to refer to the field because we're trying to assign the value in the argument to the field. And so this dot radius says, don't look locally inside this method or constructor in this instance. Look for a field called radius in this object and assign radius, which is locally scoped, to radius, which is the field up above. And so you see that a lot in constructors in Java. And it was probably explained to you at some point very quickly when you first ran into that, what was going on. And that was probably like 2 years ago. And you were like, I only kind of half understand what that person just said. And I'm not sure I care, but I can follow the pattern. And I'll just say this dot radius equals radius and things will work. And then you just never really thought about it very much after that. So that's a common place that you see this used is in situations like that. But there are times when you need to pass yourself to something else as an argument. If you're going to call a method on another object and it needs to know who you are for some reason, then passing this as an argument is a common thing to do. So as an example, there's a pattern called observer observable, where you have an observable is a thing that can possibly change. And when it changes, it should announce that it has changed to anyone that is observing it. So it's basically some object, it's often a container of some sort, whose state can change. And you can say, if anybody wants to know when I change, holler, and I'll let you know, okay? Actually, a common place where this might come up is if there's a state for a game that has multiple views. Maybe it's a multiplayer thing. And so you've got this state, whenever the state changes, everybody who's playing the game needs to have their view update. So the state is the observable, the thing that you can see. And all of the players are observers. They're things that want to be notified when the state changes. And so in the observer observable pattern, and you can Google this, it's a common thing and it's be written up all over the internet. One of the standard methods in observable is something like add observer or register observer or some kind of thing like that, that says, you know, it takes an observable, no, sorry, the observable has this method and it takes an observer as an argument and it adds it to its list of observers to notify. So you can think of it like a phone tree. Like these are the people I need to call when something happens. And if you call add observer, then you add that phone number to the list of phone numbers. And then whenever your state changes, you like call all those people and say something. And I'm getting to this part, promise. So if I'm a player, I'm the player program, and I've just joined the game, I want to become an observer of the game state. So I want to tell the game state, hey, add me to the phone tree so I learn when things change. And so I'm going to call add observer on the game state. So I'll have like state.add observer. And then the argument to add observer is an observer. And what do I pass? I pass this. I am the observer. So I use this to say, add me, my object, to the list of observers that you have. And then the observable is like, great, I'll add that to my array list or set or whatever data structures it's using to hold these things. And then it can iterate through those and say, I changed whenever something needs to be updated. So that's a place where you would need to use this, because you want to pass yourself to somebody so that they can either use methods in you directly, or in this case, store you somewhere so that they can call methods on you later on. Did that make any sense at all? I don't know if yawning silence is. Do you have a question that might help, or would it have helped if I'd drawn some things? I did all that in the air, and so
the player is this, and they're being added as an observer.
Correct.
To the observable.
Correct.
Okay.
So it's sort of like add me to the, as Utkar said, when they invite themselves to a party, it's like add me to the invitation list, and you would send this. And this just refers to, in any context, this is the object that is running the code that you're looking at. So that's going to be a player, but which player? It's actually me as opposed to you, right? We're different player instances of the player class. And in fact, in the observable case, it's probably the case that there's like an interface, like observable. I don't know, observer could be an interface. And it would probably be that player implements observer so that the observable doesn't have to know the specific class, because maybe there's multiple observers of different types, because players could be observers, but maybe there's a logging system that's also an observer. So when the state changes, it logs that somewhere. Maybe there's a scoreboard that's an observer, and when the state changes, the scoreboard updates. And so all of those could implement the observer interface. And so they're still allowed to pass themselves to the observable, who just sees them as observers and doesn't know what other properties they might have. And then Utkar was saying in the chat that it seems like there are 1,000 ways to run into race conditions. Yes, maybe, but I'm not sure more or less than any other way to handle a distributed system like that. I mean, I think it's just that distributed systems are a pile of race conditions waiting to happen, but I don't think there's anything about observable that makes that worse. And in fact, if it depends a lot on the encapsulation of the state. If the state's well encapsulated, this might make it better in some ways, but I don't know that observable makes it better. I think it's mostly like just making sure the state's well encapsulated so that observers, like a good observer should be able to see things but not change anything. And that would be important. If an observer can change things, then if there's multiple observers, I agree completely, race conditions could abound. But if the observers are mostly just reading, or entirely just reading would be better, then they're not likely to interfere with each other and things tend to behave.
What about, I was gonna say, what about when you were talking about like how set weight is set to static? So it's not part of an instant of a method.
Right.
I feel like, so aren't static methods, I guess, in that way more dangerous? Because
yes. Yeah,
okay.
Static methods can be very problematic because they're not attached to an object, they're attached to a class. Like if they really aren't attached to an object, like, I don't know, trying to think of an obvious static method off the top of my head. And there are some, like math. The math class has got a bunch of static methods. Yes. So, I mean, for example, you could, I think square root is a static method in math. So I think it's math.sqrt, and you have to pass it a number and it gives you back a number. You could have imagined a universe where it would be number dot square root, but primitives can't have methods attached to them. So ints and floats and stuff don't have methods. You can't do dot with those. So they had to put square root as a static method in math for that reason. But in general, you're better off having methods attached to an object because, as you say, then there's no question about what instance we're talking about. Like you always know exactly which instance of everything you're dealing with. And that can help synchronize behavior across multiple methods.
I don't know if other people agree in this room, but well, apart from Nick, I mean like other students. But for myself, going through data structure and even software design past that, the modifiers like static, final, and a lot of things just are kind of like, oh, that's what I saw like in class labs. So when I'm working something on my own, I'm gonna start a static there, and then like when like a editor tells me like refer to this statically, or you kind of refer to this thing like this, like create an instance of it or other stuff, or like make this function static. I'm just like, I'm gonna look up on Google exactly what the differences are, because I just added because I saw it everywhere.
And I think there are other people who have that experience. Actually, I know from answering questions and stuff that there are other people that have that experience. I think, and this is one of the things that's frustrating about Java. Like you can't do anything out without starting out with public static void, right? Because it's public static void main. And what does public mean? What does static mean? What does void mean? And static in particular, but even public sometimes, people don't really get that until quite a bit later. And they just are like, well, I know I always have to type these magic words. So boop, I will type the magic words. But they really are just like random bits of gibberish as far as a lot of people are concerned. And static, I think, is something people do not understand well until quite late in the game. We used to do a lot more Java programming and software design when it wasn't aimed at web apps and it was more desktop apps. We did a lot of Java programming. And one of the things that came out of that is people really like understood inheritance and interfaces and static and all that stuff and things like this, this dot. People understood that a lot better. But because in software design now, Java plays a much smaller role, some of those things don't get addressed as clearly as they might. And sort of just in this room, I'm a little anxious about software design next semester because my understanding is that data structures this semester, the Java stuff got covered kind of in like a day. And then it's all been data structures after that. And those people really don't understand Java very well at all. I've been talking to some of them in advising, and I think there's a number of them that are like, Java completely baffles me. And so I think that we may have to spend a little time in software design backfilling some Java and object-oriented programming knowledge that folks just don't have at the moment. But we'll deal with that.
I'm TAing that class, and that is something seems like kind of an issue.
So you've seen this from the TA end of things?
Yeah.
Okay. Well, that's actually, thank you for sharing that. That's interesting to know. Because I had like 3 or 4 students in the last 2 or 3 days be like, when we meet for advising, and I'm like, how's the semester going? And they're like, data structures, it hurts. So I might talk to you. I don't need to take up everybody's time for this, but I might talk to you, Jacob, later on about if there are particular things that you think would be good to spend a little time on in software design to get everybody kind of up to speed at the beginning. I also don't know what the registration looks like. I don't know how many people will be in the class, and I don't know how many of them will be from this data structures, how many of them will be from a data structures last year. So there's some uncertainty, but I might chat with you later about that. So thanks for sharing.
Cool.
So this has drifted rather badly from the stuff Jaden was talking about, but hopefully that discussion of this was somewhat useful. Utkarsh gave me a thumbs up, so go Utkarsh. Thank you. And oh, several thumbs up. Okay. Other questions about any of that or the stuff Jaden was talking about before we get to Ben's material? Go, Ben, go.
All right, I don't have nice, pretty slides, unfortunately, but yep, that is the right thing. So I'm just looking at the file change for now, but the big thing, if I can just scroll down to it, is that the job specification class is now entirely and completely gone.
Oh, that must have given you great joy.
Oh, immensely. It was very satisfying. So we get rid of all these helper. A lot of this is kind of getting rid of the scaffolding, which took more effort than you would think, perhaps. So I take these sort of helper functions that before you could get out of the specification, like how many tasks are there, or what's the first machine. I sort of managed to pull out and just put that logic into the job itself. But look at how easy setting up the jobs is now.
And tell us why you need the J not equal to null on line 90.
Because as a consequence of inheriting the system from further upstream, it starts at 1.
So when you loop over the specification.jobs, you get all of them, including spot 0, and spot 0 is null.
Yes.
So you've got to like see that, and this is like, and this is no way criticizing Ben. This is a criticism of the code that you got, but this is one of these things that's so annoying that the arrays start at 0, 1, because if you loop over them using the nice for each syntax, then you've got to have this if statement that says basically ignore the first one. And if you could change it so that it was 0 indexed, then that if statement could go away, and it would be even simpler. It would just be machine, get first machine, get job queue, put J, and you'd be done. And you wouldn't need the if, which would be really slick.
Yeah. And in case you're wondering why this is different, there's still pull requests waiting. So the next thing that would happen would probably be wrestling the two halves of the project together and dealing with the inevitable either merge conflicts or more likely just contradictory views of the universe. I don't think they're that contradictory. I just think they don't perfectly agree on some important things, because that happens when you change what the world is shaped like and get rid of a class.
Yeah.
A lot of just kind of cleaning up the deprecated scaffolding. A very simple, just get a single job at a single position, because that turned out to be more necessary.
So talk a little bit about the deprecation and how you used it. I think that's sort of important and meaningful.
What I did is, as soon as I decided I'm taking out the job specification, I found every function that worked with them directly, and then a little later I did the class itself and I deprecated. They still worked perfectly fine. I could still continue using them in as many tests as I wanted, but I got an obvious visual indicator of where they were being used because they were crossed out, and because the IDE was yelling at me, hey, you're using this deprecated function. And it sort of reminded me also, just, I'm not thinking about this. This is going to go away soon, so I don't want to bother trying to change it if I can at all help it. Because changing it and then getting rid of it is worse than just kind of building the thing next to it to use, if that makes any sense.
So you basically deprecated something and then built its replacement adjacent to it in some sense, with the intention of eventually then removing the deprecated thing altogether.
Yes.
Gotcha. And I think that was a really nice use of deprecation. I think I like that. And I think that was a good example of using deprecation as a way to signal intent to other people and to yourself. And as you say, the IDE is then like, this is a bad thing. So you kind of know when you've dealt with everything, because all the deprecation warnings will go away, and that would be nice.
Yeah, it also helped at the very end. Once I thought I didn't need it for anything, it made it much easier to sort of find everywhere I was using it, so I could switch it over and wouldn't accidentally miss one somewhere.
Cool.
Changing the to strings so that it works with jobs. And this is an important thing right here that I was in the previous commit, I think I kind of glossed over, which is that job specifications are hideous and ugly, but they had a use, and that use was working around the big problems with the task queues. And the linked queues had a lot of problems, so they invented the job specification to replace those with other different problems.
So what were the big problems with the task queue that this sort of made?
It's really hard to work with, mate. You can only see the front element. And it's useful to be able to see the front element, but there's also times when it's useful to be able to look at everything. And so that's why I made this toArrayList helper function in it, so that I can actually see all of the tasks a job has at a single moment.
Right.
And if the next thing I would do probably is try to clean up the task queue so that it was parameterized and ideally iterable. And then I think we could get rid of most of this toArrayList-ness, because you could just iterate through it. You could just use it.
Right, right. So basically do some of the stuff that Utkarsh and Joe did in parameterizing the queue, but then going a step further and having it implement the iteratable interface so that you get all the fun stuff that goes with that.
That would be the ideal, yes.
Yeah.
Another deleted deprecation, which I actually wasn't using for a while at all. It just wasn't being called, but I kept it around sort of as, if something goes wrong, I want to know what the old thing was doing.
Sure,
you know? And this, I'm not sure. Oh, this is just the same thing. Never mind. Task, I put a toString on for help with debugging, because it's very useful to be able to print out what a task is and have something useful come out.
As opposed to at A37259.
Yeah.
Yeah.
This right here was a one-line bug that took me the better portion of a week to find and fix. And I talked about this with you and was trying to figure out where the task's going. And the answer was that I was looking at the tasks after running the simulation, which runs through all the queues, destructively removing tasks as they're complete and moving them into the results. So I couldn't see how many tasks there were to expect to do. So literally all I had to do was move it after I looked at how many tasks there were to know how many I expected to do.
Oh, really? Wow.
And it took me multiple days to find this.
Yeah.
And that is why there is some of this weird assert true and this commented out system.error.println.
Well, I think some of that I think that system.error.println was me saying, type in a print line there so we can see what's happening in one of our attempts to fix this problem. So I own some of this badness that's left behind.
It wasn't bad. The badness is that I didn't remove it, honestly.
Well,
I don't think it was bad when we wrote it. I think it was bad that it's still here now.
I'm glad that you found the bug, because that was very frustrating.
It's infuriating when you find a really simple, obvious bug after spending half a week tearing your hair out.
Yeah.
It's satisfying, but also frustrating.
And so this is actually a really good example of the problems of side effects and state, is that, running the simulator changed other things in unexpected ways. And so that altered the state in ways that were hard to think about. And we just didn't realize that that was happening. And then you eventually did figure it out, and that's good. But state can be a real nuisance. Don't like state.
Yeah, actually, I think that making the queues iterable would also solve that because it gives you a way to find the next element without blowing up the world.
Oh, without actually remove, but then you're not really using it as a queue. You're kind of just using it as an index list or something. And it does
Yeah.
make sense for it to be a queue. I mean, it was a reasonable data structures choice, but
Yeah.
Okay, sorry. Keep going.
Yeah. I don't have to set up all of the job specifications and iterate through them in the same sort of way because job specifications had nothing in this universe had constructors, was a sort of problem in the job specification in particular. So you had to make one with an empty constructor and then assign stuff to it. Now I can just make an array of jobs and then initialize them as I go. So I make an array of tasks, which is all the tasks for this job. As I go through, instead of putting them into a single specification, I just put them into an array and then make a job with that as its list of tasks.
Cool.
And everything, you don't have to deal with all of this weirdness because things are just what they are.
Oh, so this actually, this removes the whole 2 times plus 1 nonsense.
Yes, that only exists in the input reader now, in that syntax, because the input reader, even the input reader doesn't particularly do that exactly. It sort of works according to that property because that's what the input looks like when you type in alternating numbers, but now it just takes pairs of them, makes them like I forget the exact syntax for it, because that was last commit, but just makes them into jobs straight away. It doesn't put them into this weird array of alternating integers.
Right. Cool. Well, that's a huge win because that, 2 times plus 1 nonsense is, that's just ugly stuff.
And you also don't particularly need to store num tasks in as many places. You need to know it as you're creating it, but before you had to remember how many you had because the size of the array sure wouldn't tell you.
Yeah, right. Whereas
or
now
you could kind of do it, but you'd have to do the math somewhere.
Yeah.
Um,
Whereas now you just have to say what's the length of job tasks, and that would tell you.
Yes.
Nice.
This could probably be a for each at some point, where this is for remove random machine, and this is where we get somewhere ugly, which is that in changing the world to make more sense, it was this is the one time I found them doing something approximately useful, which is that it was much easier to simply remove them when you were removing stuff for the specification generator. And remove random machine, I forget whether it was random machine or random task. At least one of them I'm pretty sure I broke. And it's not a problem because all the tests are passing. And it would only cause a problem if a task failed, because this is just in the task generation code. But this is a thing that I will shamefully confess to, that in trying to make it so these didn't touch job specifications, it was the machine got a little bit brittle in trying to remove stuff. And that is the one singular place I found job specifications doing anything that was actually useful. The others were just workarounds to their own problems somewhere else.
Yeah.
The remove random job, I'm trying to remember the details, but the big thing that I'm kind of proud of, let me actually see it. I removed 71 lines of code.
Nice.
And most of it was commented out in the previous one, but this is one of the reasons I kind of wanted to do this first, because so much stuff used the job specifications and it was screwy that I can just reduce the amount of code that there is pretty substantially. And that makes any future refactoring much easier because we have a system that's more robust, that doesn't require memorizing as much secret math, that it means that changing stuff from one index to zero indexed will in theory be easier because indexes are no longer magic numbers. And you
Right.
have to remember which you're on. They're just a list of things. And this is hubris, but it would probably take me not incredibly long to just run around changing stuff from one index to zero index. It would not be trivial per se, but it would be incredibly much easier. The only problem is that some are much easier than others. And as a consequence of that, there is a non-zero chance I would end up tormenting myself with a mixture of 1 and 0 indexed things.
Well, I think that the machine array being 0 indexed is, I think, usually the biggest pain in the butt. So Joe and Ukarsh, was that your experience? Was that the machine array was the hardest one to change the indexing on?
That's that's what I thought going in because it was connected to change over times, but it turned out to not be the case because
That's right.
I was able to do like +1 at a point where it was like where the change over times and machine were linked together. So basically, the 0th index of 1 is connected to the 1 and 1 to the 2, and I mean, yeah, like +1, and you just kind of close your eyes for a second, feel like.
Yeah, that's right. I remember that. You mentioned that on Wednesday, that turned out, you had thought that was going to be the big ugly one, and it turned out to not be that bad. So you might be right, Ben. Maybe you could clean up the 1 indexing. But certainly, regardless of that, I mean, I think this does, I mean, removing 70 lines is pretty cool. And the loops and stuff that you have now are clearly much nicer than the loops that we had before. And getting rid of the 2 times +1 business, definitely a win. So very cool. Questions, comments?
I mean, I think this is a huge deal. You're able to get rid of an entire class in place of her, so congratulations.
Yeah, it's sort of a shame that we couldn't all now take the cool things everybody's done and bring them into one new super shiny version of Machine Shop Simulator. But I think there would be merge hell of a mighty, mighty sort if we attempted to do that. But I think there've been a lot of really nice changes that various groups have made, sometimes in similar places, but actually in the second round, often in quite different places, which is cool.
I was just thinking as soon as you said that part about like, oh, wait a minute, we did parameterized queues and they have this.
Yeah, right. You know, so it would be nice if your parameterized queues could come into this, and this elimination of job specification could come into yours. And there's been some interesting renaming in some other places that would be nice to sort of capture in this. But you know, and you guys did all the indexing. It'd be nice to sort of spread that around. But you know, some of it also, different people renamed things, but renamed them different ways. And so a decision would have to be made and move stuff around, but not always to the same place and not always in the same way. And so those would clearly conflict. So I think that, you know, realistically, there's a lot of good ideas, but probably not a lot of code changes that could be carried from one project to another.
I'm kind of curious, Ben, is there, I know you mentioned it at one part, there was something specific, I can't remember, but while you were making this change, was there a part where you think like, oh, I guess the previous implementation did this better?
Exactly one part, and it was in the writing of the test code itself. not even of the tests, of the test generator. The automated testing framework liked having it. Everything else was worse. And as mentioned, it solved some problems, but what it really kind of did was just kick the problems downstream.
Yeah.
There were problems with the linked queue data structure. So what they did is, instead of using it, they made a second data structure, which they used sometimes, but not all of the time. And even as it stands, there's a little bit of weirdness in that sometimes, no, there isn't. Like, there's jobs in an array, and there are tasks within those jobs in the linked queue. And I feel like occasionally there is an array of tasks that should just never exist. But even then, we can kind of close our eyes, because the job class now has a constructor which just takes an array of tasks and sticks it into its queue. And again, constructors, I did a lot of them the previous one, but it's still just, looking back, I'm more and more realizing how incredibly important the existence of constructors is.
Yeah. And good constructors, I mean, because they're better and worse constructors, but a good constructor can make your life way, way simpler.
Even a bad constructor can make your life way, way simpler. Even if all it does is set a single field, that still makes life so much easier, because it means you don't have to run through creating them and then go and put stuff into them separately.
So, other questions, comments? Going. Yay to everybody. So we are done refactoring this annoying code, unless you feel a driving urge to continue to play with it, which obviously I do, because I keep coming back to it year after year after year. But if, on the other hand, you're a normal, sensible person, this will hopefully be the last time you ever have to deal with this code. Although, as I said, I think on Wednesday, it is, it's a neat exercise to go back and revisit this every now and then from scratch and think, okay, what if I focus on this, and what if I focus on that? Or if you've got a new ID and you're not familiar with how their refactoring tools work, like pull up the old machine shop simulator and say, let's, I'll poke at it some and learn sort of what refactoring tools they have and what they support. But for this class, we are done with it. And yay, I think everybody made some significant improvements to what is a pretty messy pile of code. And I'm very impressed with the work that folks did. So hurrah. Questions about that before we talk for a hot sec about chapter 5 of the text, which we will properly discuss on Monday. Yes, definitely Stockholm syndrome. We'll talk about chapter 5 on Monday. Somebody, I don't remember if it was Jaden or Utkarsh, somebody checked that. So there are 2 exercises at the end of chapter 5, and
it didn't work for me.
Yeah, it doesn't work for me either. Like I was going to say something about this, and I forgot earlier in the week, and I forgot. I think the problem is here. I'll share my screen actually, so we all know what I'm talking about. So this is the so there exercises, and there's 2 exercises. This code all the way down, and then deep mining, which I'll talk about in a second. But you're supposed to be able to click this link and get a certain version of the world that would be reflected by this picture. But in fact, if you click this link, you do not get a version of the world that reflects this picture. And in fact, this number here, the 4295, changes to 5 something, something, something. I don't remember, but it jumps forward in, because I think this is basically a kind of a timestamp or a which commit in the sequence of commits or something. I don't fully understand what code scenes URLs mean, but this number changes. It jumps to something else. And I'm pretty sure that something else is a later moment in time where this is just not true. Like you just don't get this picture anymore. And it looks actually like somebody read this exercise and went, well, that's dumb. We should fix it, and then fixed it. Why this doesn't allow him to go back in time and see how it was before, I don't know. But the important thing is don't look at this exercise because it won't work. Like that exercise doesn't work as a thing. And I'm sad about that, but you know, and I'm pretty sure when we did this 2 years ago, this link still did the right thing, but it doesn't now. And I don't know what actually happened there. So questions about that? Then the other thing I do want to do in class is I actually want us to sort of work through this exercise. So actually, as you know, as a group, as a mob programming exercise, actually think about, well, how could we get the median age of a file in a repository, and actually make like a little shell script that takes a file name and gets the median age of that file. I think that would be a cool and interesting thing to do. And we can learn then some useful things about how to use Git as a data mining tool directly instead of just relying on things like CodeScene to do all the work for us. So feel free to think about that. And there's a hint. So at the end of the book, there's a sort of answers to exercises, which are actually just real short kind of tips. But they suggest, and somebody added this, Ukarsh did, is to use git blame. One of the things that would be excellent start. They also suggest in the solutions appendix using the -- porcelain flag. And porcelain's a weird name. And I feel like I looked this up once, but I don't remember why it's got that name. But you can pass git blame a porcelain flag, -- porcelain, as in the stuff you make, pottery out of. And it gives you information. It gives you the Git information in a form more amenable to computer processing instead of human readability. Like it sort of does it in a way that's easier to parse with a script. And so you might like play with that a little bit and think about how we might use that. So if you haven't read the chapter, read the chapter, and we'll talk about it on Monday. And if you haven't thought about this median age of code, you might think about that some as well. And then we'll see if we can like build something together and apply it to a code base or two and see what kinds of things we learn. So questions about anything, since we're 1 minute away from done.
I noticed this Zoom meeting was being recorded, and I was wondering maybe if you want to like go back over the explanation of the static stuff and the other.
Oh yeah.
Where could we access that?
Well, you could access it by coming to my house. And no, this is actually being recorded on the Zoom cloud service. So what I will do, since you're asking, and if there were any other things that people would like to have access to, I think that by default, every class period has been recorded. But since people have typically always been here, I haven't bothered like trying to upload them. But I can totally grab this and put it on YouTube and send a link out to everybody so you could come back to this if you want. Because yeah, that's fine by me. And if there's anything else we've covered at some point where you're like, wow, yeah, that would have been useful to be able to watch again, I could certainly do that as well. So, but I can, I can make a note here that I need to post today's software quality YouTube, and I'll share a link. And I'll post it unlisted so you'll have access to it, but nobody else will. Since there's all this discussion and stuff that doesn't need to be public. But yeah, so that's a good idea. Thank you. Other questions in the 0 minutes remaining? Going. Cool. Thank you all very much. Have a good weekend. Make a snow person or whatever you do. And I will see you Monday, and we'll like data mine in Git logs. It'll be very exciting. So, ciao.